Hello and welcome to Binary, Octal and Hexadecimal Numbers Level 1. First question. Right, that's the decimal number, 88. You can tell it's decimal because of the 10 in the subscript down here. We want to write 88 in binary. And as you may know, in binary, the columns are the 64 column, we have a 32 column, a 16 column, an 8 column, a 4 column, a 2 column, and a 1 column. And we can put either 0 or 1 in any of these columns. Well, we're going to need a 64 to get 88, and that would give me a total of 64 so far, and that leaves me another 24 to find. 24 is more than 32, so we can't have a 32. If we started 1, 1, then that would make the number 96, or bigger than 96, because 64 plus 32 is 96, and that's too big, so there's no 32s in this number. However, there is a 16, because 16 plus 64 is 80, and we're trying to get 88, which is bigger than 80. So if we put those two in, a 64 and a 16, we've got 80. There's 8 left to find. Well, 8 is easy because there's an 8th column here. So we put a 1 in there, 3 more zeros. And what we have is 64 plus 16 plus 8, which is 88. So this here is my binary representation of 88. 1, 0, 1, 1, 0, 0, 0. Fine. Next one. This is astonishingly easy. That's 8 in hexadecimal in decimal. But in hexadecimal, we have columns which are the 256 column, and the 16 column, and the units column. And you can put a number up to 15 in any of these columns. Well, we can't put a 1 in the 16s column, because that would mean that the number was at least 16, and this number is 8. The only way to do that is to put an 8 in the 1s column, the units column. And that's it. 8 in base 10 is equal to 8 in base 16. So, all I have to do is type in 8. They're not all that easy. Here's one slightly harder. 35 in hexadecimal. Well, how many 16s go into 35? If you don't know, the answer is 2. You could work out 35 divided by 16, and that would be 2 point something. So we know that there are 2 16s. If we take 35 and we subtract 2 times 16, that leaves us with 3. So we need a 3 here as well. In other words, the hexadecimal number 23, what that means is 2 times 16 plus 3, which is 35. So the answer is 23. 99 in base 10 in binary. Okay, this is going to be a bit of a longer one. The largest power of 2 that is smaller than 99 is 64. So we know we'll need at least 1 in the 64s column, and that tells us that our binary number is going to be 6 digits long. It'll be a 64 column, a 32 column, a 16 column, an 8 column, a 4 column, a 2 column, and a units column. We're trying to make 99. Okay, well we've got 64. 99 minus 64 is 35. There's 35 left to find. Well, if we have a 32, then that would give us 32 of that 35, and that only leaves 3 left to find. We can't have any 16s, it's bigger than 3. Similarly, we can't have any 8s, we can't have any 4s. We need 3, well that would be a 2 and a 1. So the binary number that we're looking for is this one. 11000011. 011. Done. I'll just do one more. 3B16 in decimal, and now we're using the extension to the counting from 0 to 9 that we need for hexadecimal numbers. We count 0, 9, A, B, C, D, E, F, and then we go to 10 in hexadecimal. And B is 11. So what we have here is 3 in the 16s column plus 11 in the units column. So it's 3 times 16, which is 48, plus 11, making 59. So in decimal, it's just 59. Okay, that's about it for level 1.